Hey guys, Mike here from Arnold Tutoring with a system of linear equations question. What are we trying to do when it says solve a system of linear equations? It means here are three equations, and there could be two, there could be four, there could be 18. But the key is that we need to have the same number of variables as equations. So you can see there's an x, a y, and a z, so three variables, three equations, so we can definitely solve this. And what we're trying to do is come up with a value for x, y, and z that work for all three of these equations. So in other words, we can plug in those values for x, y, and z in any of the three equations, and it makes the equations correct. You can see how this first one is equal to 3, this one equal to 5, this one equal to 4. There's some value for x, y, and z that we can plug into all three, and all three equations are correct. So how do we find those? Well, we're going to use a combination of elimination and substitution, which we've seen before, and we're always going to start with elimination. So the first step, I'll just write it out here, is to eliminate one variable using two pairs of equations. So we basically need to pick a variable we're going to eliminate, and we need to eliminate it twice. How do we choose? Well, it really doesn't matter as long as you use our usual elimination rules. But we can be a bit clever about it to, increase our speed on the question. I'm going to look at the coefficients, or the numbers in front of each letter. You can see for x, there's 1 in the first equation, then 2, then 3, so they're all different. For y, it's 1, 1, and negative 2, so 2 are the same. They're not all the same. And for z, it's negative 1, 1, and 1. I like the fact that the z coefficients are the same. Maybe the signs are different, but the coefficients are all 1. So I'm going to eliminate z first. You'll see why that makes it easier. If I look at, I'll call this equation 1, and equation 2, and equation 3. If I look at equation 1, the coefficient on z is negative 1. Coefficient on z in equation 2 is 1. So I know if I add those two equations together, so I'm going to do 1 plus 2, that will eliminate z. Let me show you what I mean. I'm going to write equation 1 right here. I'll make sure I copy it down right. And I'm going to write equation 2 right underneath it. And I'm going to add these two equations. So we can add one equation to the other, and what happens? X plus 2x is 3x. Y plus y is plus 2y. Negative z plus z, that's 0, which means it goes away, which is exactly what we wanted, equals 8. Perfect. So now we've gone from two equations with three variables down to one equation with only two variables, x and y. Now we need to do that exact same thing again. I'm going to do the same thing, but I'm going to do equation 2 minus equation 3. The reason I'm doing minus is because I can see that the coefficients on z are both positive, so we need to change the sign. It'll make more sense when I've written them above here. Plus z equals 5, and 3x minus 2y plus z equals 4. So this is equation 2 minus equation 3, so I'm going to minus it here. Now I'm going to put brackets around this because we want to make sure we carry that minus through all the way. So 2x minus 3x is negative 1x, plus y minus negative 2y is like plus 2y, so it's plus 3y because the two negatives cancel out to a positive. Then we get z minus z, that's 0, which is exactly what we want, and we get 5 minus 4, which is 1. So again, you can see I've taken two pairs of equations, like step 1 says, and I eliminated the same variable. Now we can use either substitution or elimination to use our two equations, two unknowns, and we have other videos on this that should be pretty straightforward. I'm going to use elimination again, so eliminate one variable from your two equations that you result in. Okay, so neither of the coefficients are the same. I'm going to choose to eliminate x. So what do I need to do? Well, I need to look at the first equation as 3x plus 2y equals 8. That's coming from here. And my other equation is negative x plus 3y equals 1. So I can't do addition or subtraction right now and get rid of any of the variables because the coefficients are all different. So what I'm going to do first is multiply this by 3. The reason I did that is so that the coefficients in front of x match. So this now becomes 3x plus 2y equals 8. Nothing happened to the top equation. This becomes negative 3x plus 9y, I'm just multiplying the 3 in, equals 3. Make sure you multiply this 3 to everything. So to the x, to the 3y, and to the 1. Great. Now you can see that the coefficients on the x's match up. The signs are different, so I'm going to add the equations. And we get 3x minus 3x is 0. 2y plus 9y is 11y. 8 plus 3 is 11. So now we're down to one equation, one unknown, and we all know how to solve this, so this becomes y equals 1. Then you just work backwards and toss y back in. One level up, I'm going to put it in there. Y is 1, so negative x plus 3 times 1 equals 1. So we get x equals 2. That's just doing quick algebra. So we have x equals 2, y equals 1, and then you can plug those back into any of the originals. So I'm going to plug it back into equation 1 right here, and I get 2 plus 1 minus z equals 3. So we get z equals 0. Usually you will not get one of the variables equaling 0 because there's really no point in having them there, but that's the way that this one worked out. So it should be pretty clear. You basically use elimination 3 different times in this case. Twice in the first level to get 3 variables down to 2, then once to get 2 variables down to 1, then you just substitute back in.